Hello, my name is Jay and I'm an applications engineer here at Emerson NI. In this video, we're going to be looking at automating VeriStand. Automation is a key step in building your real-time test system, as it's how you can ensure maximum efficiency and how you can extract the most value from your real-time test system. As with many things in VeriStand, there are multiple ways of automating both the execution and the configuration of VeriStand. You can be using a test executive like TestStand, you could be using a scripting tool or programming language like Python, you could build an automation profile in something like LabVIEW. However, in this video, we're going to be focusing on automating the execution from NI TestStand. Now, for this demo, I'm going to be using one of the shipping examples that comes with NI VeriStand, specifically the engine demo, which you can see in front of you here. Now, I've configured this example to deploy to a Linux real-time target, specifically a compact Rio. Now, as I mentioned, we're going to be using NI TestStand, so I'll switch over to that now. NI TestStand is NI's test executive and automation suite. There is a lot you can do with TestStand, and we are going to be skimming only the very basics in this video. What we're looking at is using a simple sequential model to run through various test steps. And you can see that in front of you now. You can see we can open a reference to a VeriStand project, and I've done that by simply defining the path to where the VeriStand project is. We're then going to connect to it, and then we can set various channel values. These steps are all step types or test steps, and they're available to you on the left-hand side, and I can drag and drop these into my sequence file as I see fit. When you install VeriStand, with TestStand installed, these steps will install automatically, or you can install them via NI Package Manager as well. In my sequence here, as you can see, we're opening a reference to the project and setting various values. In this case, I've set the desired RPM to 2000 and set the engine power to true. Then we're going to wait 10 seconds, and then we're going to set some other values, wait a bit more, and then we're going to set everything back down to 0 at the end. Now, to show you this working, I'll just run this now as a single pass. You can see it automatically opened up VeriStand and switched to the relevant screen. It's now going to deploy to my target, and it's done that already, and it set the RPM to the 2000 that was defined in my sequence file. Then after about 10 seconds, it upped it to 3500, and again. And then lastly, we're going to set it back down to 0 and just wait for that to run down. Then if we switch over back to TestStand, you can see that it has produced a report, and you could do all sorts here. Now, this was, of course, a simple sequential model, and like I said, TestStand is a lot more capable. It can do a lot more things, but this is how you can start to automate your execution of VeriStand from TestStand. Now, an important thing to consider when building a real-time test system is to think about what is happening on your host system and what is happening on your target or real-time system. And you sort of see that in these diagrams here. So on my host system, in my case, my Windows system, I have my VeriStand UI, which is what you're looking at, and then also my test executive, for example, TestStand, or if you're using Python, that would also run on the host side. What that means is that it is running non-deterministically. So the timing is only as good as the timing of the operating system that you're running. There may be cases for your test where you need more deterministic test automation, and that you can achieve by running your tests on a real-time target instead. In this case, you can see that the VeriStand engine runs on the real-time target. In my example, I've configured this onto my compact Rio, as I mentioned at the start. In order to run an execution on a real-time engine, we need to create what's known as a real-time sequence. Now, in the engine demo example that we are looking at here, on the left-hand side, you can see a couple of example sequences. So I'll open one of these now. If I double click on that, you see it opens our stimulus profile editor, which is a tool that ships with VeriStand to create real-time sequences. And you can see that this is a sequence quite similar to TestStand, but it sets the RPM 2500 and then up to 8000. But importantly, it is going to actually wait until that RPM settles. You can use the stimulus profile editor to build a real-time sequence or Python real-time. But the important thing is we're generating a real-time sequence that we are going to deploy to our real-time target so that it can execute deterministically within the VeriStand engine. Now, we can run that directly from VeriStand, but the more interesting thing would be running that from TestStand. So if I switch back to that now, you can see I've got another sequence file here, which initially looks very similar. I open a reference to my project and connect to it, but then I can run my real-time sequence. So I've pointed it at a specific sequence, the one that we were just looking at. So what will happen now is when I hit run, it will open my VeriStand project, connect to the target, and when it does so, it will deploy that real-time sequence that we created to the target. And I can then trigger that real-time sequence from my TestStand execution here. So I'll run that now. See, it opens up VeriStand again. And we start the execution. And if you remember, we set it to 2500, and then we're going to wait for this RPM to stabilize. Now, whilst we're waiting for that, I want you to monitor the engine temperature here. You see that's slowly creeping up. If you remember, in our real-time sequence, we had set up a stop. So when the temperature goes over a certain value, it'll immediately cut off. Right, now we've gone to the second stage where we set the engine to 8000 RPM. Again, we're waiting for this to settle onto the target. But watch the engine temperature. Boom. We hit our threshold, 110 degrees Celsius, and we immediately shut off. That is a more deterministic test execution. Then if we switch back to TestStand, we see we created a similar report, and we could do all sorts with that. Now, as I mentioned, this is scratching the surface of automation that you can do with TestStand. And also, there are a lot more ways to automate VeriStand and what you can do with VeriStand than just what I've shown today. So depending on your application, I recommend you look into it further. Thank you for your time. Hope you found this insightful. If there's any more questions or you'd like further reading, please go to ni.com/VeriStand or contact your local NI representative directly. Thank you.